Linear equations in the real world. You will learn how to identify variables, find the slope given 2 points, find slope-intercept in a word problem, and much more. Defining variables. When identifying variables of x and y, picture a graph as if you were going to graph the data in a science class. X is the variables being changed or manipulated, so think about what variable is being changed or tested within the context of the problem. It will go on the x-axis or the bottom of the graph and will be your x variable. The y value is the variable that depends and changes based on the variable being changed, so think about what variable is dependent on the independent variable within the context of the problem. It will go on the y-axis or the vertical line on the graph and will be your y variable. For example, x equals the amount of gallons bought and y equals the amount of money spent. The amount of money spent depends on the gallons bought. Finding the slope. Slope is the change in y over the change in x, represented as m in slope-intercept form, which is y equals mx plus b, also known as the rate of change. Here is the formula for slope. For example, if x equals the amount of gallons bought and y equals the total amount of money spent, then the slope will be the total amount of money spent on gas over the amount of gallons bought, or dollars per gallon. Because the amount of gallons filled changes how much you've paid, because each gallon costs a set amount, known as the slope. Here's an example. Find the slope, given 2 points. Step 1. In the numerator, you will substitute 3 in for y2 and -5 for y1. Then in the denominator, you will substitute 4 in for x2 and 2 in for x1. Subtract the y values in the numerator and the x values in the denominator. After, you will have one number in the numerator and one number in the denominator. If you can, simplify or divide. So we have 8 over 2, which we can simplify to 4. So the slope is 4. Point slope form. Here's the formula for point slope. Now that we can find our slope and variables, we can use the point slope formula to get y equals mx plus b when given 2 points. Step 1. Find the slope. Remember, change over y over change in x. Step 2. Choose one of the points given. Hint, pick smaller, more manageable numbers. Step 3. Substitute the x and y values into the equation. Step 4. Distribute the slope, or m. Make sure to distribute the negatives too. Step 5. Subtract or add y1 values to the other side. Think of it as solving for y, so the y has to be by itself and everything has to be on the other side of the equal sign. Now let's try it. We already know that the slope is 4. We chose point 4, 3 because it's easy and manageable to work with. We substitute in our values for 3 for y1 and 4 for x1 and 4 for the slope. We distributed the 4 to both parts of the parentheses to get y minus 3 equals 4x minus 16. We added 3 to both sides to get y by itself to get y equals 4x minus 13. Negative 13 becomes the y-intercept. Graphing. Create a table of values. Use easy numbers to work with that also correlate with the word problem and make sense within the domain. Substitute x values, solve for y, and graph the points. In slope-intercept form, y equals the y values, m equals the slope, x equals the x values, and b equals the y-intercept. Here are your points. Also find the intercepts. X-intercept is when y equals 0 and you're solving for x, and the y-intercept is when x equals 0 and you're solving for y. Now that we have our equation, we can graph our line. Choose x values and substitute them into the x and solve for y. Here are some examples. Also find the y-intercept and the x-intercept. Here's your graph. Now try it yourself. Pause the video and resume to find your answers. Here are your answers. Remember, multiply -1/4 by its reciprocal to get x alone. This goes for all x values when solving for y. Based on information in Deep River Jim's Wilderness Trail book, the rate at which crickets chirp is a linear function of temperature. At 59 degrees Fahrenheit, they make 76 chirps per minute, and at 65 degrees Fahrenheit, they make 100 chirps per minute. Because it says that the rate is a linear function, we know to make a linear equation. First, define the variables. What is being changed in the experiment? The temperature or the chirps per minute? Picture the graph. Will the temperature be on the x-axis or the y-axis? The x-axis, as it is being changed to manipulate the number of chirps per minute. Think of it as the chirps per minute depend on the temperature, not the temperature depending on the chirps. So, x equals temperature and y equals chirps per minute. Now that we have found our ordered pairs, after we have defined our variables, we can find our slope. In the numerator, you would substitute 100 in for y2 and 76 in for y1. Then in the denominator, you would substitute 65 in for x2 and 59 in for x1. Subtract your values in the numerator and the x values in the denominator. After, divide 24 by 6 and get the slope of 4. Choose an ordered pair and substitute them in. Substitute 65 in for x1 and substitute 100 in for y1. Distribute the 4 to both parts of the parentheses. Add 100 to both sides to get y by itself and get y equals 4x minus 160 in slope-intercept form. Predict the chirping rate for 90 degrees. Since we know that temperature is the x value, substitute 90 degrees into the x value of the equation in slope-intercept form. The equation becomes y equals 4 times 90 minus 160. Y equals 360 minus 160, and it becomes y equals 200. This means that at 90 degrees, there were 200 chirps per minute. How warm is it if you count 120 chirps per minute? Since we know chirps per minute is the y value, substitute 120 chirps per minute into the y value of the equation in slope-intercept form. 120 equals 4x minus 160. Add 160 to both sides to get 4x by itself. Divide 4 to both sides to get x by itself and get x equals 70. So at 70 degrees Fahrenheit, there are 120 chirps per minute. Calculate the temperature-intercept. What does this number tell you about the real world? The temperature-intercept is going to be the x-intercept because we know that temperature is the x value. Or look at it as the temperature-intercept is when the line of the equation intersects the part of the graph that shows the temperature, which is the x value. Since we know that when the line intersects the x value, the y value of the point at which the line intersects will be 0, we can substitute 0 in for y in the equation in slope-intercept form. The equation becomes 0 equals 4x minus 160. Add 160 to both sides to get 4x by itself. Divide both sides by 4 and x equals 40. This means that at 40 degrees there are 0 chirps per minute. Sketch the graph. When sketching the graph, first label the x and y values. Find the x and y intercepts, which we had done previously. At 40 degrees there are 0 chirps, and we know because it's in slope-intercept form that negative 160 is the y-intercept. 0, 160 is not in the correct domain because it is illogical in the real world, so do not include it in the graph. This is how we found their y-intercept. Create a table of values. Substitute different x values into the equation to solve for y and ensure that x values make sense within the context of the problem. We use larger numbers because there are larger slopes and a larger y-intercept. Here's our graph. What does the chirping rate intercept mean in the real world? The chirping rate intercept is going to be the y-intercept because we know that chirps per minute or chirping rate is the y value. Now think, does negative 160 chirps per minute make sense in the real world? No, because it is impossible to have negative amount of chirps per minute or even a negative number of chirps in general. The y-intercept tells us it's impossible to have less than 0 amount of chirps per minute at 0 degrees. Y equals 4 times 0 minus 160. So y equals negative 160. This is how we found our y-intercept. Now, do it yourself. Pause the video and resume to find your answers. Congratulations, you have mastered the material.